Howdy. So this is the talk that is on the schedule, but it isn't really where my head has been in the last couple of weeks. So we decided that maybe it would be more useful if I talk about what I have been working on in the last few weeks, as have a couple of other people in the room here. You may have seen some announcements from DHS over the last couple of weeks about a very large series of DNS hijackings and IMAP credential theft. So I'm Bill Woodcock. I'm with PCH. We operate a very large DNS network. And so of the organizations that were targeted in this attack, we're probably the only one in a position to talk about it. So I'm going to give a bit of a briefing on what it is that DHS was talking about when they issued all those recommendations. So first of all, there has been a bit published on this. The first thing that came out was in the middle of November. The Cisco Talos guys published. They had a little bit of a view into it, and so what they were seeing was DNS hijacking targeting Middle Eastern governments. So that one references, I believe, Saudi, UAE, and Lebanon governments. More recently, in the third week of January, DHS did a bunch of announcements. Well, January 10 was the first one, which didn't have a lot of detail. And they've talked a bit about it since then. GCHQ, same thing. Mandiant has published a blog posting, and there have been a couple of Ars Tech articles, which, again, none of these present too much information about what happened. One of the Ars Tech articles is probably the best overview that's there, but they didn't talk with any of the actual victim organizations. So the overview they have is largely garnered from talking to threat intel folks who were themselves trying to figure out what was going on by looking at sort of little through the keyhole views that they had into the attack process. So I'll give sort of the briefing, and then I can answer questions about what this looked like. And the interesting thing to know is that this is an ongoing attack. This is not stopped or slowed down. So targets so far have been mostly national governments and critical infrastructure operators, but mostly national governments. And this is military, and it's prepositioning, right? So they're trying to backdoor things so that they can ensure ongoing access so that they can then use these assets in future attacks, right? They're not after your email. The email is a way to get into systems so that they can rootkit the systems and maintain ongoing visibility. And they've got a lot of people hours to throw at this, so they're being very thorough. The timing, Middle Eastern governments run mostly on expats. If you are a self-respecting Saudi, you do not actually do work yourself. You hire a Brit to come and do your work for you. And then you have to let the Brit go back to the UK for the holidays at the end of the year, which is typically 3 weeks, sometimes 4. So basically the entire Middle East shuts down from a governmental perspective for about a month around the end of each year. So this was how the attacks were timed. The US government also shutting down for about a month around the beginning of the year was unfortunate self-inflicted whatever here. And I'm very, very grateful to the DHS people who stuck around and did their jobs diligently through all this, despite all the problems. They worked really hard and weren't getting paid for it. So this is sort of the meat of the center of the slide deck. The way, and this is detailing how it worked with us. There were parts of this that were done slightly differently in different attacks that I'm aware of, but basically it follows this pattern. So starts with a DNS hijack. For us, they broke into the registrar EPP interface. So Extensible Provisioning Protocol is the API that registries and registrars use to talk to each other for domain name provisioning, right? So if you register a domain name and your information needs to go into the whois, or it did before GDPR, and you need to set your NS records and your DS records and so forth, all of that gets communicated through EPP protocol. And EPP, of course, is authenticated. So they got EPP credentials that allowed them to get into the registrar and compromise us and several other critical infrastructure operators that were using that registrar. That in turn passed the instructions to the registrar wholesaler, who in turn passed the instructions to the registry, VeriSign, in this case, because we were in .NET. So, interesting thing here is at each stage, there was an opportunity to validate whether the instructions were useful instructions to do productive work or were a hijack. And nobody ever did any validation. So at the registrar wholesaler level, they were very apologetic and interested in adopting new, better practices. At the registry level, I think the position is there are just too many of these folks out there. We want to let them carry the liability for mistakes. We don't want to assume that liability. Okay, so what was actually done is they used that credential to add an NS record for our domain for 1 hour periods 4 times between December 13 and January 2. During that time, in order to escape detection, they had to keep answering DNS queries. So they had their own name server that was sitting there and would take any query aimed at our domains, and it would then query Google 8.8.8.8 to get an answer, and it would hand back that answer, except if the origin of the query was from Komodo. If it was from Komodo, it would give back a different answer that went to one of their servers. The goal of which was to get Komodo to issue an SSL cert for our domain name, which they got. We were the first one that they used a Komodo cert on. Prior to us, they'd used all Let's Encrypt certs. And it turned out that no due diligence was being done there either, right? A single DNSSEC validated lookup would tell them that this was a hijack request, not a valid request. But they didn't do that. The business process, in both cases, they're documented business processes that the registrars are supposed to be following and that the SSL issuers are supposed to be following. And we've got the packet traces that show that they weren't doing it. In the SSL Certificate Authority case, I believe what the business process says is that they're supposed to do the checks, and then if the checks fail, they're still allowed to issue the cert if they want to. But we can see that they didn't even do the checks. Yes, sir. Sorry, at what level are we talking about? So, I don't know. I mean, VeriSign. The question is, what at each of these two levels, like where we have this hierarchy of registrar to registrar, wholesaler to registry, how many EPP change requests are coming in, and so like what would the ratio of hijack to valid requests be, And with the SSL certificates, what would the ratio of hijack to valid requests be? I don't have a lot of insight into that. I know that we don't make a lot of changes. For our domain, we're rolling DS keys maybe, once every 2 years or something. And NS records, there'll be, a valid change every couple of years. At the registry level, yes. Yeah, it strikes me that there are probably several million going on a day. It seems like a reasonable first pass guess. But at the same time, doing a single DNS query that their business process says that they already do. Yeah, exactly. Yeah. Well, actually, that's not the case. But for $45 a month, there is a manual process, which I will describe shortly with its flaws. So anyway, all right. So then they had an SSL cert for our domain name. Perfectly valid, unfortunately, CA cert. So then they put that into a pre-built IMAP proxying infrastructure. And they run the hijack again, right? So they're doing the hijack in these 1 hour windows and accomplishing tasks within these windows. And so then they're trying to get our internal email users to talk to their server, their IMAP server. The cert will identify it as being our server, although it's a different certificate. And then they harvest the credentials and then use that to download mailboxes, vCards, and vCals. So they were doing these 1 hour windows and they were using 1 hour TTLs. So I, knowing something about the DNS, if I were conducting this attack, I would do it in significantly different ways. Which would be less visible to somebody like me. But the fact of the matter is that this attack was marginally effective against us, and it was spectacularly effective against essentially all the other victims. And the difference between us and the other victims is we were doing DNSSEC validation. So only 2 of our clients got popped. And that was because they were traversing captive portals during that hour window. So the timing, for us, the actual hijack, there was a 1 hour window on the 13th of December, a 1 hour window on the 14th of December, and then 2 1 hour windows on January 2. And so we're not a huge organization, and we're very geographically spread out. And so it turned out that on December 2, there weren't any 2 employees in the same place at the same time, right? People were traveling, they were working from home, they were back in the office, but nobody else was in the office. And so, actually, that tees up the next slide. So during those 1 hour periods, we weren't able to connect to the mail server, right? Because our client would do the DNSSEC validation to look up the mail server IP address and would get a fail, and so we wouldn't connect. And so in their heads, all of our employees said, I don't know, it's, I'm on vacation or I'm coming back from vacation, whatever, my head isn't really in this. If this problem continues, then I'll open a trouble ticket, but I'm not going to worry about it that I'm not getting any new mail right now, right? And for a 1 hour period when you might not have looked at the beginning of the hour, some of our employees didn't notice at all. Most of them didn't notice at all that they hadn't gotten any new mail during that hour. And a few of us, myself included, noticed and thought, well, gosh, I'm in the middle of talking with my in-laws here. I'll check back again in a little while and see if it's still a problem. And I checked back in a little while and it was no problem and I had my email, right? So as a warning sign that was there, and now that we're more aware of this, we'll sort of have that more front of mind, right? But at the time, everybody being spread out, no two people. So if we'd had two people in the same office at the same time, it's very likely that one would have said, "Ah, that's funny, I can't get to my email," and the other one would say, "Ah, that's funny, I can't either," and then it would have gotten escalated. Yeah, question. So we're an Apple shop, and sorry, you mean mail client or DNSSEC? Yeah, so we're pretty much all Apple Mail on iOS and on macOS. Now, the two people who got popped, they were both on iOS devices, they were both traveling, and they both wound up having to navigate a captive portal, right? So they went off of our DNSSEC validating recursive resolver onto the captive portal recursive resolver, right? Which got them through the captive portal, but during that few moments that they were on that resolver, their mail client went to check for mail, and boom, right? So statistically, out of the whole bunch of employees, obviously this wouldn't have happened at all if everybody had been sitting in the office at that time, but we're a 24-hour shop with people all over the world, so any hour window that you pick, there are going to be some people asleep, some people in the office, some people on the road, whatever, right? So we have to find a way that works regardless, right? Okay, so another warning sign that, again, we didn't notice in advance or at the time, but we were able to see easily looking in the log files after, is when they were proxying the mail, when they had hijacked the mail server, right? They were going after our IMAP credentials. So they were looking for our IMAP connections. But because mail.pch.net is mail.pch.net, it's not separate smtp.pch.net and imap.pch.net. It's one name. They couldn't hijack IMAP without also hijacking SMTP. So they had to proxy the inbound and outbound SMTP at the same time. And I think that's a fairly common situation, right? Because their setup was built to do that, because presumably they were encountering the same thing with other organizations. When I ran an ISP, we had all this separated out, right? All these roles and functions were all on different machines or different stacks of machines, all named separately, so forth, right? So inbound SMTP, outbound SMTP, IMAP, the data store for it, all of that were all on separate things. We're a smaller organization without external customers, so we're much more like enterprise in terms of how our email is set up, and so it's just the one machine. So they had to proxy the SMTP. What that meant is that they got visibility of all of our in and outbound SMTP during that hour. Mostly it wasn't happening outbound because mostly we couldn't authenticate, or we couldn't talk to it because of the DNSSEC validation, but all the inbound stuff, nobody's bothering to DNSSEC validate. People aren't bothering to do DANE. So that inbound email was showing up on their server, and that included all of the spam. Normally, spam comes in from a wide distribution of sources. But during that hour that they were proxying, all of our inbound email was coming in from their proxy. Or not all, but all of the inbound mail that got to them due to people having hit their name server rather than ours, right? Because we have a pool of name servers and they just added one, right? So they got a bit of our DNS traffic, but not all of it. Anyway, so what that means is that almost all of our inbound spam was coming from one source during that time, which meant that source got graylisted and eventually blacklisted pretty quickly within that hour. Within just a couple of minutes, the concentration of spam caused that SMTP source to get blacklisted, which meant that inbound SMTP really dropped off during that hour. We hypothesized that because of the proxying, the DNS proxying, their DNS proxy would always be hitting the Anycast nearest instance of Google's 8.8.8.8, which in turn would always be hitting the same nearest Anycast instance of our authoritative server. So we'd see a broad distribution of inbound queries concentrating down to a very geographically specific locus. And so we did a bunch of poking because that seemed like a really good theory, but in practice it just didn't really pan out. And I don't know whether that's because Google was distributing their queries to us, or because the addition of one more name server to our pool didn't actually capture that much traffic, or because suddenly a bunch of stuff was cacheable on their side that wasn't cacheable previously because it was coming in from different sources. Got a bunch of different explanations. The answer is probably a little bit of all of that combined means that it was fairly fuzzy rather than sort of the specific thing that we'd been imagining. Okay, so the defenses. The actual one that worked for us was the DNSSEC signing of the zones and the DNSSEC validation, right? If we weren't doing the validation, the signing wouldn't have done us any good. So it's got to be the full combination. It's got to actually be happening. The first thing that we did upon finding out about the attack is we started walking the NS and DS delegation tree down from the root from a whole bunch of locations using RIPE Atlas every 15 seconds. So if this happens again and it takes longer than 15 seconds, which, again, knowing what I know about the DNS, I wouldn't take that long, we'll catch it. The third thing is registry lock. So we knew about registrar lock, and we'd had the domains on registrar lock forever. It turns out there's another service from VeriSign called Registry Lock. For $45 a month plus, I don't remember, $200 an instance or something like that, when they get I'm going to tell you the theory first, and I'm going to tell you what this looked like in practice. The theory is that when someone tries to make a change to a name server or DS record at the registry level, right? So something that's come up through EPP that affects your domain, that they will contact you out of bound and authenticate it prior to actually implementing the change. Okay? So it feels like something that you shouldn't have to pay extra for, but okay. Whatever, for that amount of money, it's not worth arguing about. So we did that. And so then the registrar, not the wholesaler, not VeriSign, the registrar sent us a PDF and said, fill out this PDF and email it back to us. And so the PDF said, what's your email address and what's your secret passphrase that you want to use? And so then we said, okay, what's your PGP key so that we can send this back to VeriSign or you or whatever? They're like, oh, we don't do that. You just send it back. It's fine, right? So this unencrypted PDF with the contact info and the passphrase on it now resides in somewhere records of the entire chain up to VeriSign, I guess. And it turns out it's not VeriSign that actually does this. It's the registrar that does it and tells VeriSign, yeah, don't worry about this. It's been done. Everything's fine. You get your money. We get our cut. Don't look behind the curtain. So this, yeah, I'm not sure it's worth $45 a month, but we'll see. All right, next thing, and a lot of this, I'm just again telling you what we did, and my wife works for Intel, and Intel already does all this stuff because they're big enterprise security IT group, right? And they get attacked all the time, whatever. So for a small organization, we're starting to look a lot more like a big enterprise organization as we have to nail this stuff down. So our IMAP server is no longer reachable from the internet. You have to log into a VPN first before you can authenticate to it. So it's just layers of security, right? And then we've got a place where we can sort of inspect all of the traffic that's headed towards it before it gets there. And if we wind up splitting, as we're now also going to do, the the structural separation between services. So inbound and outbound SMTP and IMAP all on separate machines, separate IP addresses, separate names, separate certs, all that. The inbound SMTP and outbound SMTP have to obviously be able to talk to the internet, but the IMAP doesn't have to. So, so we can separate that out a little bit more. And then a big one is using mobile device management to lock down the recursive resolver on the devices to only a DNSSEC validating recursive resolver. So, and this is really critical, right? Because if we had done this first, we'd have been okay. Because those two iPhones that were out roaming around traveling, the thing is that there's no user interface on the phone that allows you to say, only use this recursive resolver when you're trying to resolve this domain name, or only use this VPN tunnel if you're trying to reach these IP addresses. But through MDM, you can force those rules down into a phone, so, or a laptop. So on a laptop, obviously, you can hack that around down in the kernel, right, or the routing cables. But in a phone, not so much, unless you jailbreak it, and if you jailbreak it, you're asking for a zillion other problems. So MDM is a pain in the ass, but we're going to be doing it in order to get that additional layer of protection locked in. So then there were some other things that are sort of in the hypothetical, not actually queued up to do. Cert pinning and a whole bunch of other sort of CA cert band-aids all look like band-aids, right? And they're all workarounds for them, and they just don't seem like they're going to be that useful. The CA system is so fundamentally broken that trying to band-aid together something that's actually safe is, you're never going to get there. So we decided to just not try to do that, because it'd be a lot of effort, and there are other lower-hanging fruit. Client-side certs, what it kind of came down to was, it's a nice idea, but instead of using password, shared or stored credentials on devices, but it doesn't seem like it gets you that much further, particularly on modern phones that have an enclave and so forth. It's not actually that different. And it's yet another infrastructure that has to be set up, and certs have to be distributed and so forth. And then the big long-term one is DANE authentication of the IMAP server. So if we can get DANE authentication going on IMAP instead of just SMTP, then we don't have to rely on CA certs at all. So in the short term, we could go with self-signed certs and cert pinning and so forth, but again, it seems like a lot of work, not necessarily get us where we need to be. There's a question back there? Yeah, sir. Yeah. 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 So we're doing that for the VPN. Oh, sorry. So what he pointed out was that using MDM for pushing certs is actually completely doable. And so where we are right now is we're playing with the MDM still. All of this, we're less than a month out from the beginning of the attack. So the sort of bigger scale IT projects are all, we're playing with different things to see what's feasible. And so the MDM seemed really scary at first, and more it's looking like it actually will solve a lot of problems for us, and it's still going to be a pain to implement. With the MDM, what there are a ton of like in the cloud vendors whose security is way lower than ours, who we can't trust, right? And then there are a couple of good ones, but it's still an externality. And then there's only, it's not Flight, something, I can't remember. There's like one open source, commercially supported open source one that people seem to actually like, and so that's probably what we're going to try most seriously first. FLY something. It's not Flight. Anyway, okay. So yeah, potentially we could do self-signed certs, cert pin, use MDM to push the certs down and ignore anything that doesn't match those certs. What we'd really like, though, and we've been bugging Apple product security about this since 2011, but now they're taking it much more seriously because there was an actual attack that succeeded because they hadn't done it, is DNSSEC validation in the client and DANE validation in the client, right? If you've got DNSSEC and DANE actually in your phone, not dependent upon the recursive resolver, now you've eliminated all of this sort of man-in-the-middle opportunity, and you've got end-to-end security between the DNSSEC signature application at the one end and the validation on the client at the other end. And then you just have to either have your own TLD and hope that ICANN doesn't screw up, or be in a TLD where you think the TLD registry operator is competent. And of course, my recommendation is, if you got the money, get yourself a brand TLD so that you don't have so many externalities. Or be a country and have your CC TLD. Okay, so one new tool that we wound up developing internally for this is looking at that first thing that we did, walking the NS and DS delegation down from the root. The actual walking and discovery, we're just using RIPE Atlas probes to do, and then we get a big JSON feed back from that. But then we visualized that and sort of made a little tool that allowed us to, for a domain, see what all of the dependencies were and how well secured every dependency was. And we started poking around, and it's really bad. I think because of glue records and because people think, oh, more name servers is better, I'll get my buddy to be, a secondary name server for my domain, or, I registered with this, $10 a year registrar and they threw it in for free or whatever. People have name server records that are all over the place, and the glue code is coming, or the glue records are coming from all over the place, and we've got a bunch of cleaning up to do, right? But we were already in much better shape than most folks. And if you do this analysis on your domain names, what you're going to find is that there are only a few bright spots on the map. There's going to be this big spider web with only a few things that have registrar lock or registry lock or DNSSEC signing done, and very few things that have more than one of those. And there's going to be a lot of stuff that's completely vulnerable. And what you need is all three of those on every dependency in order to not have a point of entry for somebody doing DNS hijacking. Yeah. The question is, would CAA records have helped? We're getting a little bit out of my area of competence. We've got people who are in my organization who are having that argument. And my understanding is that in a belt and suspenders way, we are implementing that, but that they don't seem to have a lot of faith in it. And I haven't been paying attention closely enough to that part of the conversation to know why. Yeah. Yeah. So there's a lot of stuff that is theoretical and works well when people actively comply with it. But in the domain namespace, there are a lot of folks who are more interested in taking $10 a year than they are in doing active compliance with new security processes when they haven't even implemented the security processes that they're already supposed to be doing. So that said, we've been having conversations with both Komodo and Let's Encrypt. The Let's Encrypt guys are very interested in fixing these holes and getting it right, and the Komodo people are like, we already know everything, we don't need to talk to you. So, yeah.
Once more, go to the speculation. I think what's the end game?
Yeah.
What are these guys up to? What's the end game, and can you also speculate as to who did it? Who's doing it?
All right. So the question essentially was attribution and goals of the attack. So these are military attacks, cyber offense attacks. We are not the end target. We provide the DNS backend for 130 countries, 550 top-level domains in all, including the two-letter ISO CCTLDs for a lot of countries, but also then their IDN TLDs, the internationalized TLDs. So .hk for Hong Kong, but also then the same thing in Chinese characters, and .ae for the United Arab Emirates, but also .emirat in Arabic script, for instance. Plus then a whole bunch of brand TLDs, BMW, all the Fiat Chrysler ones, FedEx, UPS, bunch of aviation ones, right? So if you look at the list of countries that use us for their DNS backend, it includes essentially every Middle Eastern country other than Iran. So there's that. So the attack is a prepositioning attack, right? We were not ever intended to find out about the attack, and they're not going after us as individuals. And there's banking information that they had access to and didn't particularly, bite at. What they were purely going for was anything that they could find out about the countries that were working with us, and any way that they could use compromising us to get to the services we were providing for those countries. In terms of attribution, from what I just said, you probably have a guess, but I will tell you that that guess is incomplete. It's a lot more interesting than that, and that will all wind up out there in time. So, all right. Thank you very much. I'll be around the rest of the day and tomorrow.